All right, welcome to video 4 of the psychometrics refresher lecture. And in this lecture, we're going to talk about bias. And basically, we're going to talk about two types of bias. Bias that is the result of the way that people behave when taking the test, and bias that's inherent in the test itself. And we're going to start with the first one. So in all the videos up till now, so the reliability video, the validity video, and the dimensionality or the factor analysis video, we've been basically taking a really close and hard look at our measurement instrument, right? Making sure that it's measuring the same thing over and over again, making sure that that thing is actually what we want to measure. Uh, and we did that second part, making sure that's actually what we want to measure by looking at dimensionality, by looking at the content, by making sure that the relationship with other factors is the same. So we did all those components of construct validity, basically. But as I already mentioned in this validity lecture, one of the difficulties in social sciences is that our subjects, that the thing that we want to measure, react to the fact that they're being measured, right? So I think I said that when you're doing physics, an atom doesn't matter whether you're measuring it or not. It doesn't change its behavior, for example. While in social sciences, human beings adjust their behavior to being measured, which is an additional difficulty in measuring in the social sciences because it's one source of possible response biases. So people might not behave in the way that you want them to behave when taking your test. Now this has all types of problems for the validity of your test. And we're gonna look at some of the most common ones. This is an exhaustive list of biases that result from human behavior, but we're gonna look at the most common ones. Now, I already gave one example earlier in the validity lecture, and there I said that when you look at these count tables, so when people have to do 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, etc., what you're hoping to measure is just memory about some core mathematical facts, but it could be that people are just multiplying really quickly in their head. So then the response process does not match what you want it to be. Now that was a fairly innocent example, but there can be more serious ones, as we'll see later on. And the problem with these response biases is that they can be hard to detect. They can be really hard to detect. And they might bias, since they're biases, they might distort, maybe a better way of putting it, how reliable and valid you think your measurement instrument is. Because depending on how we measure reliability, let's say we're using internal consistency measures, so we only have this one measurement occasion on which we base our reliability and validity party or validity information, then the problem with response bias is that if people show the same bias on every item, then according to that internal consistency measure, there's a lot of systematic variance going on in those items, right? Because you do the same thing on each item, so you're really consistent, and that means that the reliability appears to be really, really high. However, since we're not answering truthfully, we're not using a response process of we actually want to have while making the test. We're not measuring what the test is actually supposed to be measuring. This high reliability can give a false sense of safety because it might be really consistent, there might be a lot of systematic variance going on, but we're definitely not measuring what we want to be measuring. So response bias can give us a false sense of accomplishment in that sense. It can really make the reliability look good, while validity definitely is an issue. Alright, now let's look at the most common types of response bias. Starting with the one with the most difficult name, and I think also the most difficult word in the entire course that we had, acquiescence bias. And acquiescence bias is basically just people saying either yes, 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 or no, 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 or totally agree, totally agree, totally agree, or totally disagree, totally disagree, totally disagree to every item on the questionnaire. So they don't even read the question, they couldn't be bothered, they just fill in the most extreme option. So they just go for 5, 5, 5, 5, 5, or 11111 as a score on all those items. Sometimes people are a little bit more subtle than that. They don't go for the most extreme one. So if there's a 5-point Likert scale, they don't fill in 5s everywhere. They just fill in 4s everywhere. That's like a slightly more subtle one. But the thing is, they don't read the question. They have no idea what the question says. They just totally agree or totally disagree most of the time with everything that's there. So it's basically how, I have to admit, I did some of the course evaluations when I was still a student. We always had to do them at the end of our exam. So you're already doing an exam for a couple of hours. You just want to go home. And then you still have to fill in the questionnaire. It was just like, yeah, whatever. Agree. That's acquiescence bias. Now, one other type of response bias that may seem similar at first is extreme or moderate responding, and especially the extreme part. So the extreme responding can look similar to acquiescence bias. It could look like somebody that's totally agreeing or totally disagreeing with the items on your test. The key difference between acquiescence bias and extreme and moderate responding is that in acquiescence bias, the response has absolutely nothing to do with the question that you asked. They didn't even read the question. Extreme and moderate responders do read the question. They just update their true response a bit before they write it down. And with that I mean that an extreme responder could read a statement, for example, I think that the course exam was difficult. And he or she might think, yeah, I think it was, I sort of agree with that. It wasn't an easy test, wasn't super hard, but it wasn't easy. So I sort of agree with that. But instead of writing down sort of agree, he or she writes down totally agree. So he takes his or her true response and makes it a bit more extreme. So if you agree, you write down I totally agree. If you slightly disagree, you write down I totally disagree. That's extreme responding. Moderate responding is more or less the opposite of that. So you also update your answer, but you turn it down a little bit. So if you totally agree with something, you say, yeah, I sort of agree. If you totally disagree with something, you say, yeah, I sort of disagree. That's extreme and moderate responding. So those people do actually read the questions. Third one, social desirability. Social desirability, people are afraid about what people might think of them because of the way or because of the answer that they gave to a question. So they want to make sure that they give social desirable answers, as the name already suggests. So if you have a sort of controversial opinion, you don't want to come out with that opinion. You make sure you change your answer to what you think is the socially accepted answer. That's social desirability. Depending on the topic that you give or the thing that you're investigating, social desirability might be more or less of an issue, obviously. It will probably be less of an issue on most questionnaires for psychological functioning, for example, if you're asking about attitudes and stuff like that. But still, even if you're asking about or if you're administering a psychological measurement instrument, it can happen. So if you're doing a depression questionnaire, some people might not want to admit that they thought about killing themselves. That definitely also is a cultural thing. In some cultures, suicide is considered shameful or cowardly, completely misplaced in my opinion, but still that's sometimes what people think that the view of suicide is. So even if they're really depressed and even if they have suicidal thoughts, they might not admit to it on the depression questionnaire because they know that it might not be socially desirable. So less likely to occur on when you're doing psychometric evaluation or psychological evaluation, but it can still happen there as well. Malingering. Malingering is basically you trying to look worse than you actually are. Now, this may seem really weird because the tests that you're used to are tests like course exams, for example. So why would you want to look like you know less about the subject matter than you actually do? Doesn't make any sense. True, but not all tests have the same goal. And malingering is something that happens a lot, or it used to happen a lot when there was still mandatory military service in the Netherlands. People didn't want to join the army, so they came up with a whole bunch of excuses why they shouldn't be admitted, why they are definitely not army material, and they would, for example, fake emotional instability and stuff like that in order to get out of military service. So malingering can happen if it makes sense for you to look bad on a certain test. Fifth one, careless or random responding. People basically do this when they really don't want to do the questionnaire, or when the questionnaire is really long, then at some point they get fed up. They just start filling in random responses. Again, closely related to acquiescence bias. People probably don't read the question anymore, or at least they don't read it as carefully. But whereas acquiescence responses are always totally agree, totally disagree, careless or random responses just basically fill in random responses. Sometimes they do totally agree, sometimes neutral. They just randomly select one of the possible options. This is what you would do if you have absolutely no idea what the answer to any of the course exam questions would be. You know the answer are either A, B, C, or D, so you just select A for one question, then you go to C, then you do B, then you do a couple of D's in a row just to mix it up a little bit. That would be careless or random responding. Sixth one, guessing. This might not seem like a response bias, but is actually categorized as one. This is on performance tests. In some countries, guessing doesn't happen that often. For example, in the United States, when we're doing multiple choice tests, not only do you get points for correct answers, you also get negative points. So you get points subtracted for incorrect answers. So their guessing might not be such a good strategy, because if you guess wrong, your grade goes down. But in a lot of other countries, the Netherlands included, you only get points for correct answers. You don't get negative points for incorrect answers. So then guessing becomes a good idea if you don't know the answer to a question. And guessing, so I have no idea what the correct answer is, so I'm just going to go for either A, B, C, or D, for example, is also considered a response bias. Alright, now I'm going to focus on 3 of these biases, the most common ones. I'm going to look at acquiescence bias a little bit more. I'm going to look at social desirability and stuff like that. And we're also going to discuss how we can correct for most of the response biases. Starting with acquiescence bias. Like I said, the problem with acquiescence bias is that people just go for the most extreme answer, right? And let's just pretend that for these 5 individuals, we would actually know whether they showed acquiescence bias or not. So whether they just went, yes, totally agree, totally agree, totally agree, or not. And let's say that person number 2 actually showed acquiescence bias. Person 1, 3, 4, and 5 did not. Right? So for person number 1, his or her scores are actually his true responses. Same for person 3, 4, and 5. For person number 2, the 4, the 3, the 4, and the 3 aren't his or her actual responses, because he or she didn't even read the questions. He just filled something in. Now, why is acquiescence bias such a big deal? Well, acquiescence bias is such a big deal because, like I already alluded to earlier, it can lead to an overestimation of reliability. And it can lead to an overestimation of reliability when internal consistency measures of reliability are used. So remember, there are different ways to measure reliability. We could use alternate forms, we could use test-retest, we could use internal consistency, where internal consistency could be either split half or almost alpha, stuff like that. And those different ways of measuring reliability had different pros and cons, right? So the nice thing about alternate forms reliability, for example, was, okay, we take both forms at the same measurement occasion, so there's not so much chance that the true scores changed between the 2 forms. However, it was really difficult to get exactly parallel tests. And since both forms are administered at the same time, there was a probability of correlated measurement error. So if there's something annoying happening, for example, there's problems with electricity, so you're making the test while the lights are blinking the entire time. that fluke, that accident, that accidental difficulty with electricity will influence scores on both forms, right? So that's a difficulty with parallel forms. While with test-retest, since we are administering the test at two different measurement locations, that fluke with the electricity won't influence both measures, but since we're measuring at two different time points, the true scores might have changed and people could actually remember what they answered the first time. So all different ways of measuring reliability had pros and cons, as we discussed in the reliability video. Now, the nice thing about these internal consistency measures was you only needed one test, so you didn't have to make parallel forms, you didn't have to test people multiple times. But using only one test to base your reliability on also has its possible problems. And one of the possible problems is that these internal consistency measures are susceptible to distortion when we have these response biases. Because if somebody has a response bias, for example, acquiescence bias, and the person shows that bias on each item of the test, then that person appears to be really consistent. So what's happening on each item of the test is more alike because some person answers 4 on every one of them, right? It's really systematic. Now remember that reliability looks for the systematic part of the variance and divides that systematic part by the total variance. And classical test theory assumes that that's the same as doing true score variance divided by total variance, but we know that systematic and true score aren't necessarily the same. Unfortunately, there are systematic distortions going on that have nothing to do with somebody's actual skill, and these response biases are one of those examples of systematic distortions that have nothing to do with the actual score on the underlying construct. So if somebody has acquiescence bias, then scores on the items look more similar because somebody has a 4 everywhere, and this inflates or overestimates your reliability. Alright, now to show you how large that distortion can be, let's look at the internal consistency reliability we would get for this questionnaire. And let's look what would happen if we look at the correlation between, for example, our attention deficit and our hyperactivity measures. So we're doing, we split the test in half, we split it in between the attention deficit and hyperactivity. We could have used Congos alpha, but it doesn't really matter. It's just we need an internal consistency measure, so we chose this one. Just look at what happens to the correlation between attention deficit and hyperactivity when we remove the person that shows acquiescence bias. If we leave the person with acquiescence bias, the correlation is 0.78. If we remove the person with acquiescence bias, the correlation is 0.6. So this distortion, this over-reliability this overestimation of reliability can be quite severe. Alright. Now, second one I want to take a closer look at because it's so close to acquiescence bias that it's easy to confuse it with it. Moderate and extreme responding. Like I said, it's a tendency to use extreme responses when we're looking at extreme responding or avoid them. And the difference with acquiescence bias is that people actually read the question now. So if your true response to a question is I moderately disagree, you're going to go for strongly disagree. Or if your true response is I moderately agree, you're going to go for strongly agree. Now, this has the same problem as acquiescence bias in that if you use these more extreme response options and you use it on all questions, on all items in your questionnaire, it becomes systematic variance and it leads to an overestimation of reliability, just like acquiescence bias does. But like I said, the difficulty is, or the difference is between acquiescence bias, with moderate and extreme responding, people actually read the question. Now at this point you might be going, okay, so we saw acquiescence bias, we're seeing moderate and extreme responding now, and they inflate reliability. Okay, so why do we care? I mean, higher correlations are good, right? Don't we want those internal consistency reliability measures or the test, retest, whatever. Don't we want reliability to be as high as possible? So why are we sweating this? I mean, sure, there's a distortion, but there's a distortion in the good direction, right? Well, that's true, but remember that reliability is nice, but reliability isn't enough. We don't want to be measuring something, we don't want to be measuring the same thing over and over and over again. We actually want to measure what we want to measure. If it's a test about depression, we want to measure a person's level, degree of depression. We don't want to measure a person's tendency to give an extreme response, or a person's tendency to not read the questions and just go, yeah, whatever, agree. We actually want to measure the thing that we're after. And all these response biases have a difficulty. That means that people that have the same score on the underlying construct might have different test scores, depending on whether they show the response bias or not. So if there is response bias in your sample, we can't use the observed test scores to distinguish people and to get an idea about which people will score higher on the actual construct. So if there are people that do acquiescence bias, if there are people that show moderate or extreme responding, a higher score on the depression questionnaire doesn't necessarily mean that that person is more depressed than somebody else, which is obviously a difficulty. So people with the same score on the underlying construct can get totally different observed scores, and the inverse also applies. People with the exact same observed score on the questionnaire might differ wildly on the underlying construct. So these biases mean that the observed scores aren't a good indication of what we want to measure anymore. And that's why it's something we want to avoid. Alright, now the last one I wanted to look at in slightly more detail, the social desirability one, because I want to say some additional things about it. Like I said, it's a tendency to respond in a way that's socially accepted or socially appealing. Same problems as the other ones. If people do it to every item, your reliability gets artificially inflated, and it means that you're not really measuring what you want to be measuring. But the important thing to remember about social desirability is that it can happen sooner than you might think. There are things that can cause socially desirable responses, even if you think that the question that you're asking isn't that socially sensitive. Having another human being opposite you asking the questions can already influence how people are reacting. The wording of your question can already kick in social desirability to some extent. So for example, if your question is, okay, is it true that you saw the car slam in to the other car? If you rephrase that to, is it true that you saw one car hit the other car? That phrasing will already influence a person's response. If you say the car slammed into the other response, people will exaggerate how severe the car crash was, just purely due to the use of the word slam instead of hit. So distortions can come up quick. The same applies to social desirability. It might come up quicker than you think, even with topics that you think aren't that socially sensitive. So be aware of that. Now, obviously, it is more likely when you're asking about sensitive subjects, but remember, it doesn't only happen with sensitive subjects. Alright, now, is there, I'm going to complete the entire matrix and then just walk through it with you guys. Since we have all these biases, is there nothing that we can do about it? Well, there are some fixes. No perfect fixes, but there's a couple of things we can do. And we can make a distinction between the three different types of strategies, so to say, and three different goals. So we can either try to prevent the response bias from happening in the first place. That's the first one we can do. Or we can say, you know what, there's no way we're going to prevent it. That's the second goal. But at least we can try to minimize the effect of the bias. Or if we can't even do that, so we can't prevent it and we can't minimize it, then at least you can detect that it's there. And at least we know that there's some distortion in the results. So those are the 3 levels of goals that we can basically aim for. And we can aim for those goals using different things. We can either manage the context in which a test is administered. We can manage the content of the test itself and the way that we analyze it. So we can make alterations to the wording of questions that I alluded to earlier, or we can change how we combine responses to the separate items into an overall test score. Or we can include specialized tests, so that's something that has nothing to do with the questionnaire itself per se. It has nothing to do with the things we want to measure. We just add in some additional questions that we want to use to detect response biases. Now, we mainly focused on neutral items, balance scales, and embedded validity scales in the lecture. I'm going to go over a couple more of them just so that we know that they're there. If we want to prevent or minimize the existence of bias, one of the things that we can do to the context is we can ensure anonymity. Anonymity will make people more inclined to answer truthfully. So if you want to prevent social desirability, making sure that the test is filled in anonymously, so no other person there, no investigator there, it's all done through email, in which you guarantee anonymity, etc. That will help a lot. Another thing that's often overlooked is try and minimize frustration. So badly worded questions or really, really long questionnaires don't help your validity. If it's really difficult to understand the question, people will get fed up and they will resort to careless or randomized responding or acquiescence bias because they don't care anymore way sooner than if you have clearly worded questions and you have a questionnaire that doesn't take 2.5 hours. I mean, there's a limit to people's attention span. What you can also do is warnings. Warnings help. So actually mentioning to people that you're checking for example, acquiescence bias, or that you're checking for moderate and extreme responding, will already make it less likely for them to use those response biases. Alright, that's context. Now, if you want to prevent or minimize the existence of bias, there's also some things we can do to the test itself. First thing you can do is simple items, and that basically comes down to minimizing frustration again. Make sure that the items are easy to understand and that the test isn't too long. That will make sure that people are actually engaged and answer truthfully and accurately. You can throw in neutral items. I already mentioned that one, so I already said that if you say slam into a car, people will remember the severity of the accident to be worse than just say hit the other car, so be careful with your wording. You can throw in forced choice. Forced choice is something that you don't see often, if I'm honest, but it does help to choose between 2 more sensitive options. This is also something that you see often with social desirability. So if people have to indicate whether they did something that's sort of socially frowned upon, they might not be that willing to admit to it. But if you give 2 equally socially frowned upon options that you know occur quite often, and people have to indicate whether they are more likely to do the first one or the second one, you are more likely to get more accurate results. Right, and minimal choice, and that's something you don't see often, to be honest, so we're gonna skip over that. Alright, now when sticking with the managing the test content and scoring part, if we can't prevent or minimize the existence of a bias, we can also use the test content to at least minimize the effect of it. And the most well-known example of this is balanced scales to limit the effect of acquiescence bias. Because balanced scales are basically just making sure that if you are scoring from each item from 1 to 5, then make sure that sometimes 5 stands for totally agree, and sometimes 5 stands for totally disagree. So make sure that the highest score isn't always the same option. So totally agree sometimes is a 5, sometimes is a 1. If you do that, the effect of acquiescence bias is minimized, because then people might give a score of 5 everywhere, but sometimes that 5 actually means a 1, and then the 5 and the 1s balance each other out. You still don't get valid information, so it doesn't help validity that much for those individuals, but at least you won't be overestimating your reliability as much. Correcting for guessing, well, that's obviously specific for the response bias of guessing, there are intricate mathematical ways to correct for that we also do with the course exams. And the final thing I want to mention is adding additional scales. You can either do it in managing the test content or adding specialized tests. And these scales are designed specifically to detect one or more of the response biases. They are nice. There are good ways to detect the presence of certain response biases. But remember that adding these tests makes your total test longer, even though these things are not asking about stuff that you're primarily interested in. They are really just there to ensure the validity of your results. Alright, now, that was all bias that results from people not responding to the questions in the way that you intended. So bias that results from the test subjects. There's also bias that results from the test itself. So there's also test bias. And it can be the case that the test does not perform the way you intended to perform for everybody. So it can be that you went over all this validation thing, the construct validity was all fine, but it could be that the construct validity is just fine for one specific population of individuals. So let's say you did the construct validity in the Netherlands. That's no guarantee that if you translate the test to English, it will also be a good and valid test for the English market. Now, this test bias can be distinguished into two broader categories. You could have construct bias, which means that the relationship between observed scores and true scores differs systematically for different groups. Or you could have predictive bias, which basically says that the test's use, so decision making based on the test, has different implications for different groups. Right? Alright. Now, let's give one example of each, looking at a vocabulary test in native speakers and non-native speakers. Now, it could be that if you're doing a vocabulary test, that the test score on that vocabulary test does not necessarily resemble the actual level of vocabulary for native and non-native speakers equally, right? So obviously, if you're a native speaker, you know more less used, more rarer expressions and rare words. Now, does it also mean that your vocabulary is actually better than that of a non-native speaker? Well, the answer is not necessarily. It depends on what you're looking at. So the non-native speaker, obviously his or her vocabulary in her own language is probably a lot larger than it is in the language that you're taking the test in, since he's a non-native for that test. So remember that we're already looking at vocabulary in a specific language then. If you can distinguish between native and non-native, you can already start asking yourself the question, am I really measuring vocabulary as a general concept, or am I measuring vocabulary in a specific test? So that's already an important distinction, which means that the relationship between observed test scores and actual vocabulary as a general concept is different for those two different groups. It becomes even more important when you think that people usually have a fixed number of minutes or hours to finish a test. It could be that the non-native speaker has the exact same vocabulary, it just takes more time to dig it up. So he has the exact same level of vocabulary, he's just less fluent. And then fluency also affects the observed scores for the non-native speakers, which again means that the observed scores for the non-native speakers are less accurately a description of the true underlying vocabulary than for the native ones. That would be an example of construct bias. Now, predictive bias has to do with the relationship between an observed score and another external measure, so for example a criterion. And let's say that we're going to look at the relationship between this vocabulary test and reading comprehension. And let's say that we're going to use the vocabulary test to predict a person's reading comprehension. Now, do we think that the relationship between vocabulary and reading comprehension is the same for natives and non-natives? And the answer is maybe not necessarily, because remember, it's a lot harder for non-natives to get the same score on the vocabulary test as it is for the natives, due to fluency, due to vocabulary, actually measuring vocabulary in a specific language, etc., etc. So, for a non-native, it's a much bigger deal to get an observed score of, let's say, 25 than it is for a native, right? So an observed score for 25 actually is a lot higher for the non-natives, so to say, than for the natives. It's the same number, but it's a lot harder to get, right? So that means that same observed scores are the result of a lot more work in the non-native group than they are in the native group. So it could be that the non-natives that have scores that are comparable to the natives have those scores because they read a lot. And because of that reading a lot, they manage to score on par with the native group on the vocabulary test. But if that really is the result of reading a lot, then the non-natives probably score a lot higher on the reading comprehension test as well, just because they read so much, right? They got a lot of additional practice in over here than the native group. And that will distort the relationship between the vocabulary test and the reading comprehension test. Now here I'm basically saying that this predictive bias is the result of also, in part, the result of construct bias, because the vocabulary test isn't doing the same thing in both groups. That's true, and that's often the case, but construct bias and predictive bias can also occur independently of each other. Now, how can we detect these two test biases? So how can we detect construct bias, and how can we detect predictive bias? Now, construct bias is often detected and evaluated by examining the responses to individual items on the test. And the methods that we focused on during the lecture were item discrimination indexes and differential item functioning analysis. To do that, for now, I'm just going to look at the item discrimination index. So construct bias is often detected using item discrimination index. We want to make sure that the test is measuring the same thing for different groups. So we want the items to respond and react the same way for those different groups as well. So what I'm saying is, I want a difficult item to be difficult for both group 1 and group 2. And I want an easy item to be easy for both group 1 and group 2. And if an item is equally difficult or equally easy for both groups, that gives me a little bit more confidence that the test is actually measuring the same thing in both groups. And item discrimination indexes are a way of checking whether easy items are easy everywhere and difficult items are difficult everywhere. Okay, now, how do these item discrimination indexes work? Well, what we do, and I'm going to throw in a few things in it, it's easier to talk about. Let's say we have two ways of teaching mathematics. We have the pluspunt method at the top, and we have the wereld in getallen method at the bottom. Now I want to make sure that both methods teach mathematics equally well, right? So in some high schools you get the pluspunt method, in some high schools you get the wereld in getallen method, and we want to make sure that there's no distinction between the two. So we want to make sure that students that come from the pluspunt method and go to university are not disadvantaged relative to students that come from schools that did the wereld in getallen or vice versa. So if you do a statistics exam, let's say the course exam for course 1.3, we want to make sure that that course exam is equally difficult whether you had a pluspunt in high school or the wereld in getallen in high school. So we have two groups, the pluspunt group and the wereld in getallen group, and we want to make sure that our course 1.3 course exam is measuring the same thing in both those groups. So we want to have item discrimination indexes for the course 1.3 exam, where we're going to compare the pluspunt group and the wereld in getallen group. Okay. Now, how do we do that? Well, what we're going to do then is for each question on the course exam, of course 1.3, we're going to calculate item discrimination indexes for those two groups. And to do that, we're going to look first at the course exam as a whole. Alright, so we're going to look at the final grade for the course 1.3 course exam, and those grades we're going to divide into two groups. We're going to divide them into the group of students that have high grades, and we're going to divide them into the group of students that have low grades. And here I'm going to use 25%. So based on the total score on the course 1.3 course exam, I'm going to make a highest 25% group grade-wise and the lowest 25% group grade-wise. Alright? And what I'm going to do is for the highest scoring group, I'm going to check what is the probability that if you have a high grade on the course exam as a whole, what is the probability that you get question 1 correct? What's the probability is if you're in the highest scoring group that you get question 2 correct, question 3 correct, question 4 correct. And I'm going to do the same thing for the lowest scoring group. So for the lowest scoring group on the course exam as a whole, I'm going to check for this lowest scoring group, what is the probability that they get question 1 correct? What's the probability that they get question 2 correct? What's the probability that they get question 3 correct, etc., etc. And then for each question, I'm going to compare the probability of getting that question correct between the high scoring group and the low scoring group. For example, let's say we have this question, question 1. In this pluspunt group, we see that of the people that have a high mark on the course exam, 98% get this question correct. Of the 25% that have a low grade on the course exam, only 25% gets this item correct, right? So the discrimination index for item 1 for the pluspunt group is 0.98 minus 0.25, 0.73. Okay, great. So it appears that question 1 is a reasonably difficult item for the pluspunt group. If you're really good, if you get a high grade, there's a high probability of getting it correct. But if you have a lower grade, there's a much lower probability of getting this item correct. So the difference between high scoring and low scoring groups is quite large for this item. Okay, so we know now that this item is a difficult item for the pluspunt group. Now remember that we want the test to do the same things for different groups. So since this is a difficult item for the pluspunt group, we want to make sure that it's also a difficult item for the wereld in getallen group. So for the wereld in getallen group, we're going to do the same thing as with the pluspunt. We're going to look at the total course exam for the students from the wereld in getallen schools. We're going to divide them into a highest 25% and the lowest 25%. And then for each item, we're going to check for the highest 25%, what's the probability you got item 1 correct, 2 correct, 3 correct, etc. And for the lowest scoring group, we're going to check what is the probability that they got item 1 correct, item 2 correct, item 3 correct, etc. Now, here we see that for this question, the high scoring students have a probability of 70% to get this item correct. Low scoring students have a 40% chance of getting this item correct. So the difference between high scoring and low scoring students on this item in the wereld in getallen group is 0.3. So the difference between high and low scoring is a lot smaller for the wereld in getallen than it was for pluspunt. So for pluspunt, it was a difficult question. Lower scoring people have a lot lower probability to get it correct. Wereld in getallen, it's an easier question. The difference between high scoring and low scoring students on this item is a lot smaller. So the low scoring students are doing better comparatively, basically. So the question is not equally difficult in both groups, which means that this is an indication of construct bias. The test is not doing the same thing, is not measuring equally in the pluspunt group and the wereld in getallen group. Alright, that's construct bias. And the final one, the final test bias, predictive bias. For predictive bias, we're going to look at the relationship between test scores and another measure of something. So for example, we're going to look at the test score for course 1.3, the course exam for course 1.3, and how well your grade on course 1.3 will predict how you're doing on course 2.2 or course 2.5/3.5. So we're going to see whether we can predict future scores using our test. Now, and as an example, let's say that we're going to use CITO scores to predict secondary school's first year GPA. So we're going to predict GPA using the CITO scores. So the CITO scores are the scores that we're evaluating, and GPA is our external criterion that we're going to compare against. And what we want to know is there a prediction bias? So is there a difference in how well CITO predicts GPA for children with non-native parents? Now, since we're looking at relationships between two continuous variables, our test scores, our CITO test scores, and GPA, basically what we're going to do is regression analysis. So predictive bias, we're just going to check basically with regression analysis. We want to make sure that the regression line between the test scores and GPA is the same for all our groups. So we want to make sure that the regression line is the same for children with native parents as it is for children with non-native parents. Now, that isn't necessarily the case. So the regression line can be different for these different groups. And it can be different in 3 different ways. The first way in which it can be different is the intercept can be different. So the vertical position of the regression line can be different for different groups. So it could be that children from native speakers overall get higher grades. So it could be that the grayish line is your regression line for non-native speakers, and the thick line over here, this is the line for native speakers. So we see that for each test score, for each CITO test score, the corresponding GPA is higher for native speakers than it is for non-native speakers. So the entire vertical position could be different. This is intercept bias. This means that for a given test score, one group will always have a higher score on the criterion than the other one. The second way it can be different is that the slope of the regression line is different. So it could be that the lines aren't equally steep. Gray line is again for the non-native group, the thick black line is for the native group, and here we see that the relationship between CITO test score and GPA is a lot stronger, or a lot steeper, for the natives. So an increase of 1 point on CITO test score corresponds to a larger increase, or a larger difference in GPA in the native group than it does for the non-native group. So the relationship is different. So we're not looking at individual scores. We're not saying, okay, for each test score, the corresponding GPA score is higher in this group than in the other. We're looking at differences in scores. So we're saying, okay, if 2 people differ by 1 point on the CITO test score, the amount that these 2 people will differ on GPA score is different for the native group as it is for the non-native group. So if you have 2 natives, one with a score of 3, one with a score of 4, their difference in GPA will be a lot larger than the difference in GPA between a non-native person with a score of 3 and a non-native person with a score of 3. That's slope bias. And then finally, we can have both. So it could be that we have both intercept and slope bias. So the starting position of the lines is different, and the slope, the increase in the lines, is different for the different groups. So 3 different types of predictive bias, all just tested with regression analysis. So if you want to do a test for predictive bias, you can just go to SPSS, We're going to look at the two groups that we want to compare against each other here, the native and the non-native parents, of children with native and non-native parents. We're going to make sure that you have a dummy variable for that. So we're going to give the non-native children with non-native parents a score of 1, and we're going to give children of native parents a score of 0. Remember, we can include groups in regression analysis as long as those groups are coded with 0 and 1. And then we just throw in the dummy into a regression analysis. So we're going to take the thing that we want to predict, GPA, as our dependent variable. We're going to take the thing that we want to predict GPA with, which is our CITO score, so the measurement instrument that we're testing for bias. And we're also going to include this grouping, this dummy, which indicates whether somebody has native speaking parents or not, and an interaction between this dummy and the test. And remember, the interaction is just multiplying the predictor with the dummy. We're just going to throw it all into a regression analysis and then check the results. And what we see here is, does our CITO test score indeed predict GPA? Well, yes, because it's significant. Great. That's good. That gives us confidence in the validity of our instrument. Our CITO scores are predicting GPA, so that's a good thing. Now, is there a sign of any predictive bias? No. Because if I look at the dummy, so native versus non-native speaking parents, not significant. Great. The fact that the dummy itself is not significant means that there's no intercept bias. Looking at the interaction, so I'm checking whether the effect of test on GPA is the same for both groups. So here I'm checking slope bias. Is the steepness of the regression line the same between two groups? Well, also not significant. So no difference between the groups in the slope of the regression line. So no slope bias either. No intercept bias, no slope bias. Alright, that's it for this video. After this we have one more, which is a video about legal life decision making, and I might add one or two depending on questions that come up, and I'm just gonna call those, I have no idea, the quick answers to questions video or something. But the overall themes of the course, there's only one more video for that, which is the next one, video 5, real life decision making.